All right, guys. Hope we're keeping up with side, 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 angle, side, and HL. Those are our three tools in our toolbox so far.
Yep.
And our intention is not to confuse you here, but we're going to finish up all of our shortcuts with this section. Again, you just need to keep these clear from what we've already had and what doesn't work.
Right.
Just like a lot of other problems, it's important to understand what doesn't work. And so section 4.5 is titled ASA and AAS congruence postulates. And again, you can guess what those stand for. Again, they're shortcuts to getting to the definition of congruent triangles. So as we look at the ASA one first, it stands, of course, for angle, side, angle. It goes back to side, angle, side, and the fact that that included piece needs to be there.
Right.
But now it's the side.
Now it's the side.
And so we have two angles, and the side in between those two angles has to be the one that's congruent to the side in between the two angles in the other triangle.
Right.
Okay. So again, it has to go in that order. It has to go angle, the immediate side, the immediate angle. Can't be, I'll take this angle, I'll take that side, I'll take that angle up there. You can't bounce around. It has to be the ones right next to each other in the triangles.
And the angles have to correspond to, when you...
To land on the other.
Yeah.
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 Right. Right. Okay, so two angles in the included side of one triangle has to be congruent to the two angles in the included side of another triangle. And then those two triangles are congruent.
So the other thing, too, to remember now is instead of always looking for a side first, you're going to look for an angle first.
Okay.
And so it's just a different, because side, 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 we try to find, we start with an S, so we're trying to find a side. Side, angle, side, we're trying to find a side, then an angle, and then a side. Well, now it's an angle, a side, and then another angle next to that. So it's just a switch. So when you start to look at those drawings, if you got a lot more angles than you do sides that are congruent, you got to start leaning towards these two.
Yeah, that's true.
It's a process of elimination, guys. What do you know? What can you conclude?
Right.
Law of detachment.
Yep. Okay. So we're looking at possibilities here, and so we're looking at the triangles that just what Mr. Badella was saying, looking for an angle and a side and an angle. And so if you look at that pink one, it's got the 90 degree in it, and then it's got a side right next to it, and then it's got that little angle that's marked congruent with the yellow triangle that has the right angle, the immediate side, and again that little angle there. And so those two would just slide right on top of each other. The blue one has the upper angle in it that is not even close to the measure of the other ones. And so it doesn't fit the order. That would be angle, angle, side on that one triangle, and that doesn't work with the others.
I think you said a key thing there about sliding it right on top.
Mm-hmm.
It's got to be just be able to go right on top of that other one, and everything's got to match up.
Yeah, the pieces have to land on top of each other. So.
Yep, and then angle, side, angle.
Right. So it'd be the pink and the yellow are the ones that match up here, and that would be, those two triangles would be congruent by ASA. Okay, and again, it forces the other sides and the other angle to be congruent then. Okay.
All right, so now we have angle, angle, side congruence theorem. Okay, and so angle, angle, side says two angles and the non-included side. Okay, and so sometimes this one gets a little bit tricky.
It does, yeah.
Because of that non-included side thing. Make sure they're corresponding sides when you go to match them up, because you could have a side over on this side and then a side over here on another triangle that's like this. Well, those aren't corresponding, but they could still potentially be, you could potentially get that mixed up. So watch your hash marks too, and pay attention to that. Just remember, it's not included, so it won't be in between there. But once again, we're looking for two angles and a side. So when you start seeing a lot of different angles being congruent, guys, when you're setting these up, move away from side, 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 and side, angle, side. Move more towards angle, side, angle, and angle, angle, side. So if you look at the three triangles here, the green one has an angle, and a side. Then the pink one right underneath it, if I start with my angles, okay, it goes angle, side, angle. So that sounds different. The previous one was angle, angle, side. The second one was angle, side, angle. So that doesn't work. And then once again, I start with my angle down there on the orange one, and I start with that right angle. I start with that corresponding angle from the original, and I go angle, angle, side. And so I think one of the keys to help you with this is make sure you always start in the same place on each of your corresponding triangles, and see if they match up.
Yeah.
I started at the right angle on each of those triangles, and I just kind of went through it, counterclockwise, and it didn't match up.
Yeah.
So,
Yeah, no, I don't mean to, actually, one of these is a little bit of a shortcut. So really what we've summarized here as somewhat of a shortcut is anytime you have two angles and a side, it's one of our patterns.
that's right.
You just have to know what order it goes in.
That's right.
Could be ASA or it could be AAS.
Right.
And really, the hash marks here could have been on that short side over there, and it still would have been AAS. Just the angles would have gone in the other order. Now, I don't mean to throw something more complicated in here, but I find it a little bit odd that they chose right angles to do this with, or right triangles that they chose to do this with, because there really is another one that for some reason this book doesn't cover, and I don't know why. But like the HL, there is an HA. And if you have a hypotenuse angle,
Oh, yeah.
and it would be this right here, in these particular examples, because they're right triangles, if they have the hypotenuse and either one of the other angles in a right triangle, then it fits this. And so maybe that's why they don't cover it, because it really is this, but in a way it's kind of a shortcut if it's a right triangle. Then as long as you have the hypotenuse and an angle, then by HA the two triangles are congruent. And so, and again, anytime you see a right triangle, you can either think of HL or HA, depending on what that other piece is that ends up being congruent besides just the hypotenuse. So, but officially in the book, they don't cover that one. They would use AAS for that. So, right now this, so those two, the ha theorem, yes, the laughable theorem. This is critical.
Yes.
This is a big slide right here.
One of the most important slides in the whole chapter here, guys, because
Summarizes the chapter.
yeah, it kind of just lays it out. So, first one we learned, side, side, side. Okay, there's the picture.
Yep. All three sides of one triangle congruent to all three sides of the other.
I'm just going to kind of bring them all up here, just to kind of we can kind of go through and look at things that we think about. Side angle, side, right there. ASA, angle, side, angle, right there. Angle, angle, side, and hypotenuse leg. Now, for me, as Mr. Scritchfield said a moment ago, as we're starting to go through these, you know, if you see two sides, at least two sides, then you know it's got to be side, 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 or side, angle, side. If you see two angles given, you know it's got to be angle, side, angle, or angle, angle, side. And then if you see a right triangle, it's going to be a hypotenuse leg could be part of it, and that's the only time you really got to worry about it. And then one that's not on here that Mr. Scritchfield just brought up a minute ago is if you see a right triangle and you got another angle in there, then you have the ha, and it could be hypotenuse angle.
Yeah, but this book is calling it AAS, so
Yeah,
you don't
so-
need to worry about that too much.
Nah.
If it's a right triangle, it's going to be HL in this book, so
Not always though, but it could be.
it could be.
They do some ones.
Yeah, they do that.
So that are side angle side.
Trying to trick you.
Yeah.
Yeah,
So
yeah, doesn't fit that. So there's everything we've covered so far this chapter, guys, all in one slide.
pause the video.
Yeah.
Write
Make
all those
sure you
down.
understand this. Now, it's kind of weird that they just did one triangle
Yeah.
on the slides, but anyway, you know, again, we're always looking at proving two triangles congruent and one landing on top of the other, but you get the point. The order is what they're trying to show here, so.
Yep.
Okay. So another example, kind of like we did on a few of the other sections, but now we have all of our options.
Right.
So these get a little bit more complicated in respect of just figuring out what it is. But like what you just said, I see two angles.
Yeah.
And so I know it's either angle, angle, side, or angle, side, angle.
No
There's
right
only
angle, so
two.
that's out.
No right angle. So it's got to be one of those two. And so I'm looking for a side,
Yeah.
really. I just need to figure out what side I can get from these two triangles. Well, hopefully you're catching this by now, guys, because when you see two triangles sharing a side like this, then you have to just see that. And again, I've been telling my students since the beginning of the year when we started talking about reflexive, reflexive is going to be your friend.
Yep.
It is one of the easiest steps in a proof that you can have.
Yep.
And so they both share PR. And so PR is congruent to itself by reflexive. And so because of that, the order is angle, side, angle in the two triangles. If you take one of them and just flip it around, rotate it around, it will land on top of the other one.
I think the run challenge with this question right here is when you start to get into a proof is make sure when you give out your congruent statement that you get your triangles in the right order, because I think
Yes.
sometimes students will get their
Fold it over,
Yeah.
and it doesn't work that way.
exactly. But right now we're just asking you, hey, what rule allows them to be congruent?
Yeah, no, that's a good point, though.
Yep.
Yeah. So this would be angle, side, angle.
Yay!
Are they congruent? Yes. By angle, side, angle. Okay. Want to run that one?
Sure. All right. So this one right here, you got to be careful here. All right. This goes back to the very first thing I said on side, side, side. You know, and you'll see what I mean in a moment. But we've got some parallel lines. Hopefully you guys can see that. So you got to start, when you see parallel lines, guys, 3 things should pop in your head. Vertical, alternate interior, potentially corresponding. You know, those are the 3 things you want to start thinking about a lot because they come up. You know, so here, I know that angle ACB is congruent to angle DCE by vertical angles. Okay, you see that cross, so you got to think vertical. And then I can say that angle, let's see which one maybe A is going to come in. Angle A and angle D are congruent by alternate interior angles. There's our transversal rule again.
Yep.
And then I can say that angle B is congruent to angle E by alternate interior once again. However,
So these 2 triangles are congruent by AAA.
yeah, no, there is no AAA, man.
What?
It's car insurance.
Oh.
There is
Okay.
no AAA for triangle congruence.
Oh, those are the guys that drive by the side of the road.
That's right.
Tow trucks.
That's right. You know,
Okay.
if you have to call AAA, you didn't quite drive correctly and your geometry is off when you were steering
Yes.
and you
Broke
crashed
the
or
rules.
something.
That's
Yeah.
right.
So,
AAA
anyways,
does not work.
yeah. And like Mr. Scritchfield said earlier in one of the other videos, is those triangles don't mean that ED is congruent to AB, guys. I mean, it just means they're parallel. And since there is no such thing as AAA, you know, angle can prove them similar, but they can't prove them congruent. And so this is a negatory Ghost Rider.
So that's what I was thinking on the last slide. I meant to say that on the last slide, is that we had all those reasons why we could use. It is important to know what you can't use.
Right.
AAA you cannot use. And again, if you think about it, the example is always if you put a piece of plastic with a triangle on it on an overhead projector and project it onto the screen, then the one on the piece of plastic, when you project it onto the screen, do the angles change? Do the angles get bigger? Do the lines move to make the angles bigger or smaller? No. The angles stay exactly the same. It's the
magnified.
sides that get stretched out, or the other way around, they get shrunk. And so all the angles stay exactly the same. The lines don't move to make the angles change. The angles stay the same, sides get bigger, and those triangles are obviously not congruent. The one on the piece of plastic on the overhead, you know, probably 2 inches sides or whatever, and they're probably 4 feet up on the projector screen. And so AAA does not work. AAA is basically blowing a triangle up or shrinking it down. They're not congruent to each other. So, even though it may look like it there. Okay, right triangles.
Hey, right triangle. So
I'm
I got,
thinking HL.
yeah. So it could be HL here.
Could be, but we don't know.
You know,
that.
but I mean, so we got one angle and one side right now, so we're still kind of in a weird realm.
Right.
You know, but right angle's in there, so we got to start thinking HL.
And the piece is the hypotenuse.
Yeah, and so the piece is the hypotenuse, so that's good. And so basically we know that TV is congruent to TV. And so now I have a set of legs. I have the longer sets of legs in each triangle that are congruent to one another. So I have hypotenuse leg.
Yeah, so it does work.
I mean, hypotenuse leg really is one of the easier ones to pull out most of the
Yeah.
time. You
Yeah,
know.
but you got to have the right triangles to do it.
Yep.
So,
Any more? Dun, 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 dun. So, here we go. A couple different ways you could go here, maybe. But you got to be careful. Okay, so some of you might be thinking, hey, those are parallel. They're not. They're congruent. RS is congruent to UV,
yeah.
but not saying that UV is parallel to RS, so don't make that mistake.
Make sure
Okay.
you see how this diagram is different than the one right next to it.
Yeah.
They're not parallel.
They're not parallel. So the only really thing I can pull into this is vertical angles. Okay? And so now I've got 2 angles and a side. So I got to
I
think.
just have to figure out the order.
Yeah, so I got angle, side, or I got angle, side, angle.
Mm-hmm.
Well, I got an angle, and then a side. So I'm going to start with an angle because that's what I want to do. It's not
There's 2
SAA.
angles here.
You know, I'm going to go angle, side. So angle, side. So that works there. And then go the other way. Angle, side. It works there good.
Right.
So what do you say, Mr. Scritchfield?
Well, yeah, and the side is not between the 2 angles.
That's right.
So it has to be angle, side.
There we go.
Okay. All right, and we'll just do more examples like this, guys. So make sure you understand these, and we'll do more in class.